Before we have a look at other pieces of interpretation in ANOVA, first let us spend some time to understand the underlying calculations in the ANOVA table. Let's start with degrees of freedom. We would know that it defines in how many independent ways a factor can vary. So for city, which is the factor here, it would be 1 less than the number of levels r. That is r minus 1, or in this case the factor city has got 3 levels because we have 3 cities in the example. So the degrees of freedom for city would be 3 minus 1, that is 2. That's what is shown here. For the error term, which aligns to individual data points, since we have subgroups in this case, it will be limited by the number of subgroups. So degrees of freedom will be total number of data points n, which is 30 here, minus r, which is nothing but the number of subgroups, which in this case is 3. So degrees of freedom in this case will be 30 minus 3, that is 27. Then we have sum of squares. So for the factor, it is the sum of all the squared differences between the overall mean and individual subgroup means, multiplied by the subgroup size, which in this case it is 10 here. So those of you who would have gone through the previous section of this tutorial would find it easier to relate it now, because this piece we had explained in detail in section 2. Like if we take the example of city 1, it would be the square of difference between 15.74 minus 15.74 is the overall mean, minus 13.04, which is the mean response time for city 1, multiplied by 10, which is the subgroup size. So that's how we get 72.75, and sum for all 3 cities would be 128.59. Sum of squares for error is given by the overall sum of all the squared differences between the subgroup average and each of the individual observation in the subgroup. Like for first data point for city 2, it would be the square of difference between 16.10, which is the subgroup average, and the individual data point 15.13. This equals 0.94, and sum for all 30 observations calculated like this will add up to 24.02. The total sum of squares is the sum of squares for factor and for error, and that would be 152.61, that is 128.59 plus 24.02. Now coming to mean sum of squares, which represents the variance, it is given by the ratio of sum of squares and degrees of freedom. So for factor, it will be sum of squares for factor divided by degrees of freedom for factor, that is 128.59 divided by degrees of freedom, which would be 2. So that comes to 64.30. And here we need to remember that mean sum of squares represents the subgroup variance. Then we have F stat, which, as we said earlier, is the ratio of mean sum of squares for factor and error. So that is going to be 64.3 divided by 0.89, which comes to 72.29. Now looking at the remaining calculations for the metrics that we see in the ANOVA table. Next is the p-value. Now the p-value represents the cumulative probability function associated with the distribution. In this case, we are talking about F distribution. Now we have calculated the F stat, which is 72.29 in this case. Now to know the p-value, what we need to find out is this critical value of 72.29 corresponds to what probability. So if you really want to calculate, and if let's say you use Minitab quite often, then it's very easy to do. In the menu, you need to go to Calc, CALC, and within that look for probability distributions, within which you will find F distribution. Now since we want the cumulative probability, which is the total area covered in the distribution, what we do is we choose this calculated F stat of 72.29 as the input constant, and then we need to mention some variable like let's say K1 to store the resulting probability what Minitab is going to calculate. So once we run this test, we will get the probability to be stored in K1. So 1 minus K1, when we calculate, we get the p-value. So that's about the p-value from a calculation standpoint. Now looking at the remaining metrics, we see S here, which is 0.94. Now S is the within sample standard deviation, or also called pooled standard deviation, and it is the square root of mean sum of error, which in this case is 0.889. So square root of this value, we get 0.94. So that's the pooled standard deviation or within sample standard deviation. The next metric is the R squared value, the coefficient of determination. Now R squared value is given by 1 minus the ratio of sum of square for error and sum of square for, the total sum of squares. So which in this case it will be 1 minus 24 divided by 152. So that comes to around 84.26%. The last metric is the R squared adjusted, which basically accounts for any dummy variable in this ANOVA, and it is given by 1 minus mean sum of squares for error divided by the ratio of total sum of squares and total degrees of freedom. So that basically becomes 1 minus 0.89 divided by the ratio of 152 and 29. That is what that's how we get 83.10. So overall, this is how the calculations are done when it comes to the ANOVA table. I hope this video was useful. We would always be delighted to see your likes, comments and mails, as we consider you an integral part of our learning endeavor. Keep watching this page as we plan to host more learning videos on concepts from DMAC, Lean, DFSS, re-engineering, theory of constraints, BPM and operations research. Please do subscribe to the page and keep receiving updates as and when we upload a new tutorial. Do share the links or channel details in your group so we end up creating a much larger learning community. In case you want us to talk about any specific concept, feel free to contact us. The contact details are mentioned here on the slide as well as on the page. So good luck and happy learning.